Hello, I'm Sri from CBTU. CBTU presents a course on Amazon Web Services. Section AWS Glue, Managed ETL Service. Agenda for this session: Amazon Glue introduction, features, benefits, use cases, terminology and how it works, pricing, demo. Build AWS Glue data catalog, transformations, and run jobs. AWS Glue is fully managed extract, transform, and load service (ETL service). You can create and run ETL job in few clicks. AWS Glue is serverless, no infrastructure to manage. It automatically provisions the environment to complete the job. These are the benefits. AWS Glue automates ETL jobs. AWS Glue crawls your data sources, identifies data formats, and suggests schemas and transformations. AWS Glue automatically generates the code to execute data transformations and loading processes. It is well integrated with wide range of AWS services. Glue is serverless, no infrastructure to provision or manage. You pay only for the resources used while your jobs are running. AWS Glue is developer friendly. Let us see how it works. Select the data source and data target. AWS Glue will generate detailed code in Scala or Python to extract data from the source, transform the data to match the target schema, and load it into the target. Manage Glue in simple 3 steps. Build your data catalog, generate and edit transformations, and schedule and run your jobs. Use cases: queries against an Amazon S3 data lake. Crawlers scan your datasets in Amazon S3 and populate Glue data catalog. AWS Glue data catalog serves as a central metadata repository for Amazon Athena, Amazon Redshift, and Amazon EMR. The data is available for analysis using Amazon QuickSight and other BI tools. Analyze log data in your data warehouse. Amazon Glue, in fact, glues all the services from data sources like Amazon S3, RDS, feeds Redshift, and other BI tools, or pushes log notifications to the CloudWatch. Unified view of your data across multiple data stores. The data from Redshift, S3, RDS, and EC2 is fed into Glue data catalog. Glue reads and writes the metadata to Glue data catalog and feeds Amazon Athena, Redshift, EMR, and use BI tools for analysis, for running reports and visualizations. This is event-driven ETL pipelines. It is integrated data catalog, automatic schema discovery, automatic code generation. Glue provides developer endpoints and flexible job scheduler. Pricing: with Glue you pay an hourly rate for crawlers and ETL jobs. For the AWS Glue data catalog, you pay a simple monthly fee for storing and accessing metadata. Under the free tier, you have some free offerings. ETL jobs and development endpoints. Pricing is based on the number of DPUs, data processing units, used to run your ETL job. Data catalog storage and requests. Crawlers. There is an hourly rate for AWS Glue crawler runtime to discover data and populate the AWS Glue data catalog. Back to presentation. Use cases. AWS Glue terminology. AWS Glue interacts with several components to create and manage your data warehouse workflow. AWS Glue Data Catalog is the persistent metadata store in AWS Glue. Each AWS account has one AWS Glue Data Catalog. It contains table definitions, job definitions, and other control information about Glue environment. Database is a set of associated table definitions organized into a logical group. Crawler. A program that connects to a data store, source or target to determine the schema for your data and then creates metadata in the AWS data catalog. Table is metadata definition that represents your data. Table defines the schema of your data. It can be Amazon S3 file, Amazon RDS table, or another set of data. A table consists of names of columns, data type definitions, and other metadata about the base dataset. Transform is the code logic that is used to manipulate your data into a different format. Job, the business logic that is required to perform ETL work. It's easy to understand this terminology during demonstration. Let us log into the console. This is AWS Management Console. Search for Glue. AWS Glue is under Analytics. Select. This is AWS Glue console. A database is a set of associated table definitions organized into a logical group. In this demonstration, we are using a flights data in CSV format in the year 2016 stored in Amazon S3 provided by AWS. We catalog its metadata, transform data in the AWS Glue data catalog. As part of data catalog, we create table in database, create connections, create crawler and run crawler, and ETL. We create jobs and run jobs. Let us create a crawler which creates tables and database. A crawler. A crawler connects to a data store to determine the schema for your data and then creates metadata tables in your data catalog. Let us use the wizard to create database and tables. Let us use the wizard, add crawler. Let us use the crawler name, flights data crawler. Crawlers invoke classifiers to infer the schema of your data. We use built-in classifier for CSV. We can use custom classifiers as well. Description is optional. Security. Security configuration to enable at-rest encryption on the logs pushed to CloudWatch. Go with default none. So let's go with the defaults. Next. Data store. Choose Amazon S3 as our data store. And for the data, we have flights data in this S3 bucket, this S3 location. Select, leave default. Next, another data store. No. IAM role allows crawler to run and access your Amazon S3 data stores. Let us give the name. The role it's going to create will be AWS Glue Service Role - default role. We can create manually, but this wizard creates it for us. Next, we have already configured this. Let us choose the existing IAM role. We have this. Let us select this. Next, create a schedule for this crawler. We can select hourly, daily, or other options. Let us go with run on demand. Next, choose the database. We don't have a database. Let us add database. Let us give the name flightsdb. Location description optional. Let us create is created. Let us enter flights prefix for our tables. Configuration options. Let us go with default. Next, review our configuration. Finish. We created the crawler and we are ready to run. Close. This is the database that is created. Until we run the crawler, the table will not be created. Crawler. This is the crawler we have created. This is configuration. Let us run this crawler. It takes a minute or so to crawl against our data source and to create the table. As it's run, it took 43 seconds. One table added. Let us see the table. Refresh. Flight CSV. This is the table. These are the fields. This is schema. You can view table details, properties. The flights data is partitioned by the month. We can view the files and view the properties for each partition. View file links take you to the Amazon S3 console to view the data. This is for the month August 2016. This is for the month June 2016. You can view the files here. This is the partition data for all the 12 months. Close partitions. If we have different versions, we can compare the table versions. Edit table. Cancel. Edit schema. The column names in the table originate from the data store definition. You can modify the data types for this or delete any if you want. Let us cancel. Tables. This is the crawler. Logs. Logs helps in troubleshooting. Let us add a job. A job is your business logic required to perform, extract, transform, and load ETL work. Job runs are initiated by triggers which can be scheduled or driven by events. We have cataloged metadata in our AWS Glue data catalog. This is the data that is in CSV format, and we want to convert CSV files to Parquet format. And while doing that, we can drop some fields which we don't need in data analysis. Let us create an ETL job. ETL job is to extract, transform, and load relevant columns in flights data from Amazon S3 source to an Amazon S3 target. Let us add a job. Let us give a name. Choose IAM role. This role has permissions to access Amazon S3 sources, targets, and temporary directory scripts, and any libraries used by the job. A proposed script generated by AWS Glue. And this name is transformed here. ETL language. It can be Python or Scala. Let us go with default Python. S3 path where the script is to be stored. This is the temporary directory. Advanced properties. Security configuration, script libraries, and job parameters. Let us go with the defaults. Next, data source. Our data catalog contain table. Choose flight CSV table which contain metadata definitions that describe our data and schema. Next, choose data target. Create tables in your data target. We'll choose the Amazon S3 data store. Format. Select Parquet. Apache Parquet is a columnar storage format available to any project in Hadoop ecosystem, regardless of the choice of data processing framework, data model, or programming language. Apache Parquet is a binary file format that stores data in columnar fashion, similar to RDBMS format. It is one of the big data storage formats. Main advantage is it has efficient data retrieval, efficient compression, etc. And it is supported by Apache Hadoop, Hive, Spark, Extra support, Parquet files by default. Target bucket, let us select CB AWS Glue. Next, we can map the source columns to the target columns. We can verify the mappings by AWS Glue. AWS Glue generates your script with defined mappings. We can delete some columns. Let us delete one column. Next, this is job properties review. Save job. This is the script that is generated. This is the diagram for the ETL flow that is generated. Let us run job. We can review parameters and run job. Let us go with the default. Click run job. Our job is running. The job log messages are shown here in the logs tab. Once the job is completed successfully, we will see transformed flight data in parquet format in our target S3 folder. This is the target bucket. It is empty now. The job is still running. These are log messages. The job run has failed. Let us see our S3 folder. This bucket is empty. This is access issue. Okay. Let us quickly create another job. Choose default role. Script file name is this. S3 path for the script. Leave default. Leave temporary S3 directory. This one. Next. Data source is this. Next. Create tables in your data target. S3 data store. Format parquet. Target path. Let us select glue temporary. Next. Mapping. Leave default. Let us click next. Let us save job and run. Save. Run. Parameters. Default parameters. Run job. Glue temporary. This is the bucket. Yeah, it's creating folders. Job is running. These are the output parquet files split into different parts. We have 23 files. This job is run successfully. Save, close, job 2. This job is successful. Log files. Log files are stored in CloudWatch. These are the metrics. On this job, we can take these actions. If a job is taking a long time to run, you can stop the job. We can create and choose the job triggers. We can edit job, edit script, and create a development endpoint. As we have seen, Apache Parquet is big data storage format. Parquet files are column storage and compressed files up to 1/10 of the original file. In the Apache Hadoop session, we will go through Parquet files for data analysis. This job is run for 1 minute and the timeout defined is 2880 minutes. We can create triggers, schedule, frequency, at what time, job events, succeeded, failed, stopped, on demand. On demand is we run the job manually. Endpoints. Billing for the development endpoint is based on DPRs. A development endpoint is an environment used to develop and test your AWS Glue scripts. We can set up development endpoint in 4 simple steps. A notebook enables interactive development and testing of your ETL scripts on a development endpoint. We'll go through these features in another session. And as a final step, when we don't need the database anymore, let us do the cleanup. We must release all the resources. Let us delete this database. Deleting a table will delete all the associated tables. Is deleted. Table is deleted. Crawlers. We need to delete manually. Delete. Done. Jobs. Jobs we need to delete manually. Okay, this is brief introductory session of AWS Glue. Back to our presentation. Tables, database, crawler, CloudWatch logs for Glue crawlers, crawler, partition data, schema, job run failed due to Amazon S3 access issues. Job run successfully. Glue jobs output logs in CloudWatch. Job succeeded. Data written in Parquet format in destination S3 bucket. The data transformed into CSV. The difference between the Parquet and the CSV format. Parquet files are extremely compressed to 1/10 of the original file. We have seen AWS Glue Console to discover data, transform it, and make it available for search and querying by other BI tools. We'll catch up in another session with another demo. Thanks for watching.